At the North Pole, the weather conditions are so cold that the ocean freezes. The ocean is comprised of a salt and water solution. Water freezes at 0 degrees Celsius, but salt doesn't freeze until it's much colder than that. So frozen seawater is very different to a cube of ice that you'd use to cool your drinks. First, the pure water freezes and pushes out the salt, which is not frozen, into the surrounding water. As the temperature decreases, more pure water freezes, and the salty water becomes trapped in pockets in between the ice, forming a matrix structure of solid ice and liquid pockets of salt water, which eventually join together to form channels. This is called sea ice and forms the Arctic ice cap. The small-scale honeycomb structure of sea ice is responsible for two processes which have an impact on a global scale. In the summer, temperatures in the Arctic increase enough for the sea ice to melt at its surface. The meltwater can drain away through the saltwater channels. Sometimes there is enough water to collect on the ice surface. Whereas ice reflects the energy from the sun very effectively, water absorbs the energy from the sun, so the ice beneath the water melts more quickly, forming deep ponds. Over winter, the ponds which haven't drained away freeze over, covering the surface of the ice with a new landscape of depressions. The following summer, the snow and ice melt again. They fill up the depressions made in the previous years. The small-scale honeycomb structure of the ice is what allows the ponds to form on the surface. The ponds, which can be many meters long and cover much of the ice surface, greatly affect the amount of energy absorbed by the Arctic, which in turn affects our global climate. Also, the salt water that is pushed out of the ice as it freezes is very much more salty than the surrounding ocean, and cold, which means it's dense. This influx of salty water is responsible for creating ocean currents. So a process that starts on such a small scale, with pure water freezing and pushing out pockets of salty liquid, is responsible for processes on a global scale.